Hello students. So today we are going to learn integration by parts. Now integration by parts, in this topic there is a fixed rule to integrate this type of integration. You can see that this type of integration where u and v are in the product form. That means it clears that whenever any two functions u and v are in the product form, that is in the multiply form, then that type of integration is done by using the rule of integration by parts. Now first of all we will learn what is the rule of integration by parts. Okay, now here what we have to do, we have to give out of this two function u and v one function as first function and another one as a second function. We have to give them a position, one as the first, another one as the second. Later on I will teach you how to give this first function and second function to whom u or v. Okay, so now the rule, suppose here I have given u as the first function and v as the second function. Now the rule says that, just remember the rule. First of all, first function, starting with the first function u, integration over second function v. Okay, just remember that always the second function will be going to integrate. So starting with the first function u, integration over v dx, that is second function, minus integration over, give a third bracket. Okay, starting with the first function, integration over v dx minus integration now derivative of first function, now again into integration of second function, third bracket close, dx. So this is all about the rule. First of all we will assign out of these two functions one as first, another one as second. Then we're going to starting with the first function, the u is our first function, integration over v dx, v was our second function, minus integration over derivative of first function into integration over second function. You can see that always the second function is in the form of integration and first function at the first term it will comes out of the integration, and for the second terms it comes in the derivative form and over dx. Okay, now how to assign first function and second function. So there is a fixed rule. The rule is that very simple. Remember this word, islet. Now what is the abbreviation of this word, islet? I stands for, so this is the abbreviation of islet. I stand for inverse. Inverse means those function inverse, that is sine inverse x, cos inverse x, and this is not included in your syllabus, so we will not consider the I part, that is the inverse, but this is not in the syllabus, but the rule is for islet only. L stands for logarithm. Logarithm means log x type function or log x square, log 1 plus x, etc. It can be any form, but it is in the form of log x. Okay, A stands for algebraic. Algebraic means the polynomials you know, that means we can say 1 is also a polynomial, x, x square, x plus 1, anything in terms of x. Algebraic. T stands for trigonometric, that is some sin x, cos x, etc. But again trigonometry is not included in syllabus, so we will not find any question regarding trigonometry also. And E stands for exponential, that means e to the power x, e to the power x plus 1, e to the power 2x, etc. Okay, so this is the rule. The rule says islet, that means I for inverse, L for log, A for algebraic, T for trigonometry, E for exponential. Now how to use this rule? Suppose we are integrating integration, I'm just giving one example. integration over x e to the power x. We have two functions here multiply, one is x, another one is e to the power x. Now first of all, the first thing is that we have to assign first function and second function. Now first and second are given to this priority list. Which function comes at first, we will give them at the first function, and which comes at the second and the last, we will give them as second function. Now x comes under the category of algebraic, and e to the power x comes under the category of exponential. Now here we can see that the algebraic comes at first, so we will assign x as first function, and exponential comes at last, so it will assign e to the power x as second function. Clear? Suppose I am dealing with this type of integration x log x dx. Okay, so x means algebraic, log x means logarithm. Now here we can see that the logarithm comes first, so we will assign log x as first function, and x, that is the algebraic, comes after the logarithm part, that is a, so we will assign x as second function. So clear how to assign which as first and which as second. Just simply use the rule of I let. And this was the formula of the integration by parts. So now we will directly start solving some integrations. So let's start. Okay, now question number 1, integration over x e to the power x. Now x e to the power x, so first of all we have to assign first function and second function. So for that we have to use that I let property. Okay, so x come under the category of algebra and e to the power x come under the category of exponential. So from here we can see that algebra comes earlier, that means the x will comes first and e to the power x as second, because it comes under the exponential. Now we have to use the integration by parts formula. So similarly here x indicates your u and e to the power x indicates your v. So using that rule, first function, that means x, integration over second function e to the power x dx minus integration derivative of u means our first function, integration over v, that means our second function, close our dx. Now simply integrating them, e to the power x integration is e to the power x minus integration ddx of x. Now we know that ddx of x is 1, integration of e to the power x is e to the power x, and they are in the form of multiplication, third bracket closed, dx. ddx of x, that is simple derivative of x is 1 into integration of e to the power x is e to the power x. Plus c we have to give, because out of the two integration, one integration is already solved, so for that we have to give plus c. Whenever you find that out of the two integrations in your solution part, one of the integration is already solved, so for that particular you have to give plus c. Now 1 into e to the power x is e to the power x dx plus c. So x e to the power x, integration of e to the power x is, we know that e to the power x plus c is already given, and for more simplification you can take common e to the power x from these two terms, x minus 1 plus c. This is the integration of clear. So in this way we are going to use the integration by parts. This is easy, but just you have to remember this rule. Everything is easy here. Okay, now let's proceed to the question number 2. Okay, next integration is integration over x square e to the power x dx. Now x square, again x square comes under the category of algebraic, and e to the power x come under the category of exponential. So algebraic means it comes earlier than exponential, it is our first function, and exponential is our second function. Now using the I let rule, that integration by parts rule, first function integration over second function minus integration over derivative of first function integration over second function dx. Okay, x square integration over e to the power x is e to the power x minus derivative of x square is, we know, 2x into integration of e to the power x is e to the power x dx plus c, because one integration is already solved. X square e to the power x minus, so what comes here, 2 is a constant, let us take 2 out of the integration, 2 integration x into e to the power x dx, so plus c. Okay, now here we can see that the first part is normal. Okay, we got the answer minus 2, and now for this part there is all again integration over x e to the power x dx. So again here we can see that there are two functions in the form of multiplication. That means again we have to use here integration by parts. Clear? That means again we have to assign x as first function, e to the power x as second function. Then again for this particular integration we have to use integration by parts. That is x square e to the power x minus 2. Now give a bracket. Let us use a second integration by parts for this one. X integration over e to the power x dx, or simply you can do like this also, it is more simple. Give this equation as number 1. Okay, we will solve it separately, then we will put the answer here. It will be easy for us for the calculation. That means give this equation number 1, you will write here integration, what we require, we just require this part. That means we will write x e to the power x dx. Then we assigned by using the eyelet x as first function, e to the power x as second function. We have done now only the question number 1 is this only. Again we will going to solve first function integration over second function minus integration ddx of first function integration over second function dx. That is x to the power x minus integration ddx of x is 1 into e to the power x integration is e to the power x dx plus c. 1 into e to the power x is e to the power x, and e to the power x integration is, that means 1 into e to the power x is already e to the power x, and its integration is plus c. That is, we can write e to the power x taking common x minus 1. Not required for this part c, because already one c is given, so we will not write here c, because already we have used one c, so no need to write, because we are just solving this part, because for this part already c is there. So now what we'll do, just putting this value in our expression number 1. Okay, so from 1 we are finding this integration x square e to the power x dx equals to the first term x square e to the power x minus 2. We have find this integrating value as e to the power x x minus 1, and last term plus c. So this is your answer. Clear? Now let us proceed to the question number 3. Question number 3, integration of log x dx. Now as we know that there is no direct formula of integration of log x. There is no direct formula of integration of log x. So here we have to solve this integration by using the rule of integration by parts. But again one question arises, here only one function is there, log x. no another function is there. That means no u, no v, just only one term log x. So how can we use here integration by parts? Because integration by parts is basically for the multiplication of two functions, but here only one function. So here what we'll do, we will represent this integration into the multiplication of two functions. Now see how. 1 into log x, you can write. Now eyelet rule, 1 is also a polynomial, that means it comes under the category of algebraic. Log x comes under the category of log x. So here log x comes earlier, so that means it is our first function and 1 is our second function. Now using this integration by parts formula, first function log x, integration over 1 dx minus integration derivative of log x, integration over 1 dx and full closed dx. Okay, now we know that 1 dx means dx only. Okay, 1 dx means dx only, and we know that integration of dx is x. Integration over dx is x. ddx of log x is 1 by x by the derivative formula. And again, integration of 1 dx means what? 1 into dx is always dx, and integration over dx is, we know by the formula of derivative, by the formula of integration, integral of dx is x over dx. Now here log x into x can be written as x log x. We will not write in this form log x, not in this way. If you multiply, so it doesn't represent anything. It represents like log x into x, like that. So you will not write in this way, you have to always write in this way, x log x minus, now here 1 by x into x, that is x cancel, so what remains? 1 dx, or one part is solved, so we will give plus c x log x, integration of 1 dx is x plus c. So this is our answer. Clear? Very simple integration, just you have to remember the integration by parts rule. Okay, now proceed to the question number 4. Okay, again same form of question number 3. So here again we have to write integration over log x square as integration over 1 into log of x square, as we have to use by parts. So for that we require two functions, and again 1 comes under the category of algebraic and log x square come under the category of log x, that is logarithm. So L means this comes first function and 1 comes under second function by using the eyelet. Now using this integration by parts rule, log of x square first function integration over second function minus integration derivative of first function integration over second function to dx. So here log x square into integration of 1 dx is, we know that x minus, now derivative of log x square. First of all, whatever the, we know that for log, whatever the here directly comes as 1 by x square. Now by chain rule, ddx of x square, that is 2x. So this is the derivative of log x square. In rough I am showing that part, ddx of log x square. So first of all, whatever is here that directly comes 1 by x square, or simply you can take like that, let by chain rule u equals to x square. So it becomes ddx of log of u. So now ddx of log of u, that is 1 by u. Now by chain rule, du by dx, now putting the value 1 by x square ddx of x square, that is 1 by x square ddx of x square is 2x. So that thing, ddx of log of x square, I am written 1 by x square into 2x. So that thing I have written here 1 by x square into 2x. Clear? Okay. So now integration of 1 dx is x dx. Okay, now just multiplying, we write x log of x square minus, now x into x, 2x into x, that is 2x square, and in denominator it is x square dx plus c. Now x square cancel, 2 comes out of the integration, only what remains, x square cancel gives 1 dx plus c, that is x log x square minus 1 in dx integration is x plus c. So this is your final answer. Clear? So now let us proceed to question number 5. Now one short trick note for you, because these types of short trick notes basically helps for solving the MCQ type questions. It will save your time. So what is the note says that if you are integrating over e to the power x and in a bracket you find the two types of form, one is f of x, that is whatever your function, plus that another term is the derivative of f of x, that is I am written as f dash x. Dash, as we all know, that is a differentiation of f of x. So if you find this type of form, that is e to the power x in a bracket, one is a function plus another one is the derivative of that particular function f of x into dx, then that answer is directly you can write e to the power x into f of x. Now you can see that how this simple line is useful while solving the big type of integrating formula questions. Suppose the question number 5, integration over e to the power x divided by x. Many times this question comes in your exam, many times. If I say plus 1 dx, integration over e to the power x by x into x log x plus 1. So first of all, let us try to make this given question in this form. That means, see, starting there is only e to the power x, but here what is the e to the power x divided by x. So let us take this divided by x in the bracket. That means e to the power x only remain out of the bracket, and let us multiply 1 by x to each term. That is x log x divided by x plus 1 by x dx. Okay, so that is integration over e to the power x. So here x and x can be cancelled, so what remains? Log x plus 1 by x dx. Now let us compare e to the power x, e to the power x. Okay, log x, so we can treat log x as here f of x. We can treat log x as here f of x, and we can focus here what is the derivative of log x. We know that ddx of log x is 1 by x. So that means this is our, in compare of this term, this is our f dash of x, that is derivative of log x. So whenever you will find that type of form, that is e to the power x into a function plus its own derivative 1 by x, so that answer will be directly write e to the power x into what I said here, f of x. What is the f of x here? Log x plus c. So this is your answer. Simply what you have to do while using this, you have to, in bracket you have to mention like that, using which rule? This rule. Just simply in the bracket you have to mention that you are using this particular short trick. Just remember, you can mention that using this, you have to write this whole line. Clear? Very simple. And if someone doesn't want to use this short trick and simply use the integration by parts rule and then find the answer, just tell me, I will solve in that way also. Okay, both the way are possible because this short tricks comes by using this integration by parts rule only. So if someone wants that he or she wants to solve this type of integration by using the integration by parts rule, then just mention me, I will solve in that way also. But for the time being, just remember this rule, e to the power x into f of x plus f dash x. One is function, another one is its own derivative, then your answer will be e to the power x f of x. Clear? Okay, now let's proceed to question number 6. Question number 6. Now basically this short trick is only applicable for your MCQ parts, not for your theoretical question comes. If suppose a question is for 6 marks, this type of question comes for 6 marks only, and you are using the short trick, then you will get only 3 or 4 marks. Okay, these short tricks are only for your MCQ part. And for theory part, if you are using the short trick, that in that time you have to prove this short trick while using this, then you can get 6 out of 6. That means whenever you are mentioning a short trick, that means you have to mention that short trick, from where you are getting that. You have to prove that first of all, then you can use this short trick result, and after that you get 6 out of 6. Otherwise, if you are directly writing the short trick and solving the answer, you will get 3 or 4 marks, not the full marks. So integration over e to the power x 1 by x minus 1 by x square. So first of all, we can represent in this form, that is integration over e to the power x 1 by x. The minus can be written as plus in this way, plus minus minus, we know that. Now again e to the power x, e to the power x, let us give f of x as 1 by x. Okay, let us give f of x as 1 by x. And what is the derivative of 1 by x? We know that d dx of 1 by x is nothing but minus 1 by x square. So this is our derivative of, that is, this is our nothing but here f dash of x. So by this short trick rule, what will be the answer? E to the power x f of x, that is e to the power x into, what is f of x? 1 by x plus c. Just you have to remember, mention here using that dot 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 means that short trick. You have to remember write this full line, and that is finally our answer is e to the power x by x plus c. Clear? Question number 6. Question number now 7. Okay, now question number 7. Integration over x e to the power x divided by 1 x plus 1 whole square dx. So let us first of all convert into this particular form, that is short trick form. So how will we represent? First of all, we represent x in a new way. Now see how to represent this x. We can represent x as x plus 1 minus 1. We can write x as x plus 1 minus 1. Denominator will be same, and e to the power x is out of this. Okay, now let us separate them. Separating means dividing each term by x plus 1 whole square. That is, first term x plus 1 divided by x plus 1 whole square minus 1 divided by x plus 1 whole square, and in the bracket, out of the bracket, e to the power x. Now x plus 1 divided by x plus 1 whole square, that means it will cancel and one term will be cancelled here. So from where we get 1 by x plus 1 minus 1 by x plus 1 whole square plus into e to the power x dx. Now again this, if you want to convert this full form in this short trick form, so here is a plus, so here is a minus. So for what we have to do, we simply write here plus and give this minus in the second bracket. Okay, now e to the power x, e to the power x. Now from here what will be our f of x? Simply see that one form is 1 by x plus 1, another form is minus 1 by x plus 1 whole square. So now you can simply guess that if this is your f of x, so if this is your f of x, that is 1 by x plus 1, and what is the derivative of 1 by x? We know that derivative of 1 by x is nothing but minus 1 by x square. Derivative of 1 by x is minus 1 by x square. So similarly, derivative of 1 by x plus 1 is nothing but minus 1 by x plus 1 whole square. Just in place of x I am writing x plus 1. In place of x I am writing x plus 1. So here for you have, so by now see that these two terms, one is 1 by x plus 1, another one is minus 1 by x plus 1 whole square. So from here you can just remember that which one is your f of x and which one is your derivative of f of x. Simply this is your f of x and the minus part is your derivative part. So by using the short trick you will get your answer e to the power x f of x, that is e to the power x f of x is 1 by x plus 1 plus c, that is in final e to the power x divided by x plus 1 plus c. Okay, just you have to mention that using that line. Okay, now question number 8, integration x plus 2 divided by x plus 3 whole square e to the power x dx. Now again we have to represent x plus 2 in the form of x plus 3. So very simple, x plus 2 can be written as 3 minus 1, 2 can be written as, and denominator x plus 3 whole square, close this, e to the power x dx. Now x plus 3 give it in some bracket form. Now let us separate them, that is x plus 3 divided by x plus 3 whole square minus 1 by x plus 3 whole square e to the power x dx. Okay, now let us dividing. So after dividing it gives us 1 by x plus 3, and this minus part can be written as plus minus of 1 by x plus 3 whole square bracket close e to the power x dx. Clear? Just first of all dividing, we will get 1 by x plus 3, this minus part can be converted into plus, plus minus. Now again like the same part, same question, question number 7, this is our f of x and its derivative is 1 by x plus 3 derivative is minus 1 by x plus 3 whole square. So this is our f dash of x. So just by using that short trick rule we can write e to the power x f of x. What is the f of x? F of x is here 1 by x plus 3 plus c. So finally the answer will be e to the power x by x plus 3 plus c. Just you have to mention at the side that you are using this rule. Just you have to mention that rule. Clear? So last 4 questions are the important one from this integration by parts. Now all the 4 question, last 4 question I have solved by using the short trick. Now out of that 4 I will solve one of the question by using the integration by parts rule. For the students who are thinking about that what we'll do by without using the short trick rule, how to solve that one. So for them only, the out of the last 4 questions which I have done today, I am solving one of the question by using this integration by parts rule. Question number 5. Question number 5, integration e to the power x by x into x log x plus 1. So this question we have earlier had done today only, and I have seen the how to simplify, just multiplying s and we will get log x plus 1 by x dx, right, without using the short trick. Okay, now first of all multiply by e to the power x. So e to the power x log x plus e to the power x by x into dx. Now separating the integration, e to the power x log x dx plus integration e to the power x by x dx. Name this expression as 1. Clear? First of all, just we simply multiply and then e to the power x, then separating the integration into two parts. Always remember this type of where you have to separate it into two parts. Now again, just have to focus from which part you have to simplify. Same rule. You can see that log x and this is 1 by x. So we can see that 1 by x is a derivative of log x. So which is the main f of x? This is your f of x log x. So we will solve this integration part, not this one, not the derivative one. Where the f of x is there, what was the f of x? Here log x. And what is the derivative? 1 by x. So we will going to solve this f of x term. Okay, so then you have to write now e to the power x log x dx. Now using the chain rule, and that is Eilert rule, not chain rule. Logarithm comes under the category of log and e to the power x comes under the category of exponential. That means log x is our first function, e to the power x is our second function. So by using the chain rule, first function integration over second function minus integration over derivative of first function integration over second function into dx. So this was the rule, that is log x into integration of e to the power x is e to the power x minus ddx of log x is 1 by x into integration of e to the power x is e to the power x dx. No need to c, okay, let the c here plus c. Now let us simplify from e to the power x into log x minus into this means plus c. Now let us put this value into expression number 1. Okay, so then from 1 so now putting the value in the expression number 1, the first term was integration e to the power x log x dx. So integration e to the power x log x dx, we have to find the value. Let's put that e to the power x log x minus e to the power x by x dx plus the second term was integration to the power x by x dx and the last plus c. So now after putting the value, we can see that one term is cancelling out, minus integration to the power x by x plus integration e to the power x by x. So these two terms are cancelling out. So at last what remains? Plus. This is your answer. Okay, so in this type of question you will find two terms. After that you have to integrate only one of the term and by using the integration by parts rule, and then you have to put the value. You will find the second term, that second term, this is the second term, is cancelling out. Okay, similarly in the question number 6, I will not solve, just giving the hint to you. First of all, multiply. You have to multiply it. Now separate the integration. Now again we are getting two terms. Name this expression as 1. Now out of that we will solve only one term. Now which term we have to solve? Just remember the main term, that is 1 by x, because we know that 1 by x derivative is 1 by x derivative is minus 1 by x square. So we will only solve the 1 by x term. So if by using your integration by parts rule you have to solve this one, that is it can be written as e to the power x into 1 by x dx. We can write by Eilert rule 1 by x, that is algebraic, comes first e to the power x comes second. So by using integration by parts rule, first function integration over second function minus integration over d dx of first function integration over e to the power x dx second function to dx. Integration of e to the power x by x minus integration over integration over d dx of 1 by x is minus 1 by x square, as we all know. Integration of e to the power x and finally dx. Now minus minus plus, and multiplying this e to the power x by x square dx, and put here one c. Now putting this value in this expression, because we are finding this expression, so putting this value in this expression, putting the value of this expression, that is e to the power x by x plus integration e to the power x by x square dx. This was the expression we have got from by integrating by parts, this minus already there, and last plus, and these two parts are same, we will going to cancel. So finally your answer is clear. So how to solve without using the short trick? Okay, now question number 7. This question is very important for exam purpose, that's why I am doing the both short trick as well as the without short trick method, both for MCQ as well as your theoretical part. So first of all, let us express in that same form, that is expressing x as x plus 1 minus 1 divided by x plus 1 whole square, in the same form e to the power x dx. Now after dividing, I am just writing directly, after dividing, that is in the bracket, after dividing we will get 1 by x plus 1 minus 1 by x plus 1 whole square into e to the power x. We have already solved this type earlier. So now again 1 by x plus 1, and its derivative is 1 by x derivative is minus 1 by x square. Okay, that means now you have got that which term we have to integrate by part. Now let us multiply and separate them. Name this expression as 1. Just separating them, multiply by e to the power x and then separating, integrate. Now which term we have to integrate? We have to integrate this term, the main term. Okay, because this is the derivative of this term, x plus 1 whole square. 1 by x plus 1 whole square is a derivative of 1 by x plus 1. So again that is e to the power x into 1 by x plus 1 dx. 1 by x plus 1 is your algebraic that comes into first form, and this is our second function. Now using your integration by parts rule, first function into it will not come here. First function integration over second function minus integration over d dx of first function integration over second function dx. Okay, that is integration over e to the power x is e to the power x divided by x plus 1 minus d dx of 1 by x plus 1 is nothing but minus 1 by x plus 1 whole square into derivative integration of e to the power x is e to the power x dx. Now here minus minus will comes plus, and this multiply will simplify, give you e to the power x. Okay, plus c. Now putting this value in the expression number 1. That means for in this place putting this value, we will get, putting the value, we will get e to the power x by x plus 1 plus integration e to the power x by x plus 1 whole square dx minus integration e to the power x by x plus 1 whole square dx plus c. Now these two terms are same, so that means these two terms are going to cancel. So finally your answer is x plus 1 plus c. Clear? So these are the integration by parts without using the short trick. So this is all about the integration by parts. So here the most thing you have to remember, the most important was this rule. Rest of things are very similar, very easy. Just this rule and how to determine which one is first function, which one is second function. So just follow these all questions. And okay, one bonus question or one homework for you. Today I didn't give any homework to you. So one homework to you: integration over x log of 1 plus x dx. Try this one. Okay, this is one homework for you, question number 9. So try this one, and this is all about integration by parts. If you face any doubt regarding any particular step or any formula, just tell me, I will try to resolve them. Okay, so thank you for watching this video. Goodbye.